might cut it out. We'll see. Come on, come on, come on, come on. Oh, there we go. All right. All right. So you guys online, that was your time frame, whatever, 12:03 to have it done. I'm going to not really go specifically over the bell work, but we're just going to talk about the quiz as it relates to word problems. So on the quiz, like I said, it's recording, right? Yeah. On the quiz, I'm already up to 6 word problems. I'm not sure I'm done. So a large part of this quiz is going to be doing something with word problems. Well, not every one is going to be like you have to define the variable and create the rule and then set up the equation and solve. Some of them are just pieces. Like maybe you just create the equations. Maybe in one of them I define the variables for you and you just solve. So, but there are a lot of word problems. This lesson it's very easy to use word problems in this lesson. So let's talk about how to get at least partial credit. That's what this bell work is about. What questions can I ask myself when, like Alondra said, when I zone out and I completely lose focus on a word problem? What can I start asking myself to help me get some credit on the word problems? So we've got this word problem. What does anybody have something as far? I mean, I don't even make it that hard. I'll be honest. That's why I don't feel too bad for you on quizzes. I don't even make you change the number. Like sometimes in word problems, these wouldn't even be the numbers that would go in the word problem. You'd have to do some math to these first to figure out what number goes in the word problem. I don't even do that. Those are the numbers that will be in the word problem. What else will be in the word problem? And then, I'm sorry, in the equation, not in the word problem. What else is in the equation? Variables, right? I mean, you got, like that's it. You got the numbers that are going to go in there, and you know there's going to be an x and a y. If you just put all of those into an equation, or sometimes 2 equations, which I'll tell you also the next thing, we've been doing 2 equations for 3 weeks now, systems of equations. Pretty good chance the word problems are going to be about 2 equations. So there's your next hint. When you're seeing a word problem, you better be thinking, I probably need 2 equations, not just 1. A lot of you on the last test, even though, again, we've been doing 2 equations for a week or 2 at that point, you just tried to make 1 equation. It's 2 equations. And we're going to explain exactly how to know that for sure, but let me ask you this other question. What would make sense if I'm creating 2 equations? Give me a number out of there.
10.
10. Boom. Oh, 10. What would make sense to go with that 10?
X.
Well, no, not a variable. Another number.
Oh, 0.15.
Why?
Because it says and then per month.
Those numbers are both about Spotify, right?
Yep.
And then you
If those numbers are about the same service, then I'd put them in the same equation.
You put a variable in
We're not doing that yet. I'm trying to give you baby steps. If you guys already know how to do the equation, that's fantastic. Right now, I'm doing it for the people struggling.
I'm not doing equations.
So these numbers better be in the same equation. Sometimes I got people putting them in 2 different equations. Nope, that would be a bad idea. So again, iTunes 3 and 45 better go in the same equation. They're about iTunes. So there's your first hint. I don't know how you explain that, but the numbers that are together in the word problem need to go together in the equation. Nobody wrote it down. That's why you don't.
Oh.
That's because I already know.
Hold on. I don't.
Trust me. Not everybody already knows, and nobody still wrote it down.
Hold on. Could you say that again?
Again, this is why I don't feel bad when I grade. And I grade harder and harder when I see you guys not doing notes.
You could ask nicely and say, could you say that again? Could you say that again?
I'm deciding if I'm even going to say it again. Because again, that's another problem. Like, I should not have to say it again. Like, why would I say it again? I said it. I'm literally told you, this is about how to get points on the quiz. Nobody's writing it down. Apparently, nobody's even listening. Why do I care then? Talk about you don't care. Maybe I don't care. How about that?
Why are you pointing at me?
You actually do your work.
You say I care.
You just talk through the whole class nonstop. Other than that, you do all your grade is fine.
The 10 and the 0.15 are supposed to be in the same equation because they're both butterfly numbers. You're not supposed to put them in 2 different equations.
Oh, I said we know that.
So the word, so I'm saying the numbers that should match up from the word problem need to go in the same equation.
Okay.
I don't know, again, the reason I wasn't gonna say it again, what I say may not make sense. You need to kind of use your own words for that. Like you need to, so that you understand it when you look back later. Because the way I say it may not make sense. So, but the point is, these two numbers are about that service. So they need to be in the same equation when you create equations. These two numbers are about iTunes. So when you create the other equation, those two numbers need to be in that other equation. All right, what's a number that we almost always have? Like a type, how do I spell it? It's not a type of number. It's something that we almost always have in a word problem, and that leads to an equation. We almost always have a blank number. It's normally the big number. Total. We have almost every single word problem we've done, we've had a total number. Every single time we've had a total number, it's been at the end. It's been all by itself at the end. If we knew it. If we didn't know it, then it's been what?
A variable.
A variable, which is normally going to be y, which we'll actually get to that in a second. So you're asking yourself, is there a total number in there? Is there?
No.
There's not. There's not a total number given. Is there an unknown total?
Yes.
What is the unknown total? Why would you say that?
A variable.
It would be. If it's an unknown, it would be a variable. So that's another thing, and we'll get to that next. Looking at this problem, what is it we're trying to figure out or compare? She's comparing services, but what does that mean? What numbers is she actually going to be comparing to compare the two services?
Total number?
Yeah, the total. So there's absolutely a total. There's almost always a total. I can't think of a problem we did where there wasn't a total. If you can think of one, let me know, because I can't. We went in and we bought stuff in a store. Well, we had a total dollar amount and a total number of items we bought. We ran a 100-yard dash. Well, we had a total distance we had traveled. We had a bank account. We had a total amount of money we had saved. We had people going on a field trip. We had a total number of students. Like there's almost always a total. Always. So you need to think, what is my total? Do I know it? Do I not know it? How many unknowns do we have in this then? What was the unknown we just said? We just said total, right? So we don't know total. And in this case, it's total money she spends. So I'm just gonna write total money. How many totals are there?
There should be two.
Two.
Wow.
Because it's two questions.
And the
Two equations, I meant two questions.
iTunes.
There's two services, but that will lead to two equations. So that's the next question. First of all, you say, is there a total?
No.
Well, no, there is. We just don't know it yet. So there is a total.
Unknown.
We aren't given that total yet, but there's an unknown total. And that's what we're doing right now, are the unknowns anyway. Unknown. And we're going to come back to when the total is known. That also tells you something wrong, especially when I create the quizzes, which I am. So what's the other unknown? And there's going to be two totals, one for Spotify, one for iTunes. Here's the next thing you make sure you write down. Points on a quiz. No, you don't. What am I about to say?
For the next one?
Oh, actually, maybe you do, because I saw it in somebody's notes. I think I saw it in Ella's notes. What am I about to say?
You're about to, for the next
No, I'm not moving on yet. It's about totals.
Oh.
Okay, say what you gotta say.
If
First.
you have-
What do you have written down that I told you would have been good for the bell work?
If you have two totals, they could be unknown or not, and you need two columns.
You should already have that down. She already had it down, but I'm going to say it again. If you have two totals, it could be known, like you could know what they are, like they say, he spent a total of $10 and he bought a total of 7 items. That's two unknowns. I'm sorry, that's two totals. But in that case, we know what they are, 10 and then 7. This case, we don't know what they are. We don't know how much money iTunes is going to be, and we don't know how much money Spotify is going to be. So in this case, they're unknown. Doesn't matter if they're unknown. If you have two of them, two totals that are supposed to be in the problem, you need two equations. You can't have one equation where you're trying to fit in two totals. It's never, ever going to happen.
So what was the thing?
I'm about to say, because all I got is.
If you have two totals, whether you know them or not, like if they give you the totals, or if the totals are unknown, like in this, we don't know what the totals are, you're going to need two equations. Two totals. And I'll show you how knowing them versus not knowing them changes the way we do the equation in a minute. We're getting to that. But basically, if you know that there are two total amounts, you're going to need two equations. So right now, we're dealing with when they're unknown, because we're doing this problem. So if they're unknown, what does that mean? What do we do with unknowns?
You find them out.
But before we can find them out, what do we have to do? You said it earlier.
You did?
Yep, sure did. Sure did.
It makes it harder.
Make it harder when you said it.
Now he's trying to think
No
back to
sense
what he
at all.
said.
Yeah.
What is an what? Actually, the opposite. Then I give you the answer. What do we do with unknowns? What do we say about an unknown? Unknowns are the
Variables.
Variables. Thank you. So if you don't know, that's why I'm asking the question. What are the unknowns? Unknowns are going to be your variables. So whatever you don't know. Normally that'll come from the question, but in this one I didn't really ask a question on purpose, so that you couldn't just look at the question. So the unknowns are going to become your variables. So what variable would we use for a total? An unknown
X
total.
or Y?
To be specific. Well, yeah, pick one.
X,
X, Y, X,
X,
X.
Y, X, Y.
X, Y,
X.
X.
Where's the unknown? Where's the total normally go?
What the heck?
To X.
Why?
Well, where does the total normally
What are
go
you
in the
talking about?
equation?
At the end, at the end.
At the end. The only equation we have where a variable is at the end is this. That's the only equation. X is always in the middle somewhere. X is pretty much never all by itself. So Y is going to be our total. So here's the next thing you write. If your totals are unknown, Y is your total.
I know where the X goes.
Right there, by the M.
I know. Well.
Was that wasn't the door, was it?
No.
All right, so here's the next. I think I said it, but if you didn't hear me. If you have totals and the totals are unknown, your equation is going to be in this format right there. Y is going to be by itself. You're going to have a number that's going to be all by itself as well, and then you're going to have a number times X. That's the format when the total is unknown. And I'm going to come back and once we do the equations, I'm going to write this again next to it. So I'm going to erase it for now.
Cool.
All right, so what's the other unknown? What else do we not know besides the total?
How many downloads?
Yeah, perfect. We don't know how many downloads. That's an unknown. She might download 0, she might download 10, she might download 100. So the other unknown is how many downloads.
So I got the equation.
Yeah, your equations were good. From what I remember.
Why were mine wrong?
I don't remember. Did I say they were wrong?
Yeah.
Oh, I don't remember.
Well, you said.
So let me ask you this question then. We had two totals, right? One for Spotify, one for iTunes. How many X's are we gonna have? How many variables? Is it?
Yeah, because it's two different equations.
Does anybody think it's not two?
Wait, what?
But it's two different equations.
Four? Oh, somebody thinks four. Wow.
Yeah, it's 4. Yeah.
It's
There's
two
X and Y, two
different
different
equations.
equations.
Let me ask you
One
this.
for each equation.
I'm comparing services, right?
Two.
I'm going to compare services. Would I want to do this? I want to know my total amount I spend with Spotify, my total amount I spend with iTunes. And I want to do that by downloading 10 songs from iTunes, but 30 songs from Spotify. Is that going to be a good comparison?
No.
Or maybe I want to download 3 songs from Spotify and 100 songs from iTunes. Is that going to be a good comparison?
No, because it's not equal.
So are there 2 X's then? Because don't we want to make sure?
Don't the X go behind how many downloads because you don't know
Yeah.
how many downloads. So it would just be one X.
Has
How
to
would
be
it
good.
be?
I'm trying to confuse you. Here's the deal. It kind of depends on how you look at it. you're going to have two equations, and each equation is going to have an x variable in it. That's true. So if you look at it that way, then yeah, I've got x in both places, so there are two x's. X is always going to be the same number, though, because I need to do the same number of downloads in both situations to know if it's a good comparison. Like, so there's no there's no set answer to that. No, there's gonna again. There's no set answer. There's two x's because there's one x in one equation and one x in another equation. But the value of that x has to be the same if you're comparing.
Wait, time out.
Let me give you two more examples, and this may help.
No, back to the question.
Well, no, let me give you this, then this may clarify your question. Remember the race, right? When I raced Contreras, we both had an x in our equation. My equation was y equals 20, because 20 was my head start, 20 plus 6x. We both had an x. His was y equals 8x. So we both had an x, but the x value was always the same because it was the number of seconds. So when the clock or the gun went off and we started counting seconds, his seconds were always the same as my number of seconds. So again, if the value of the x is always going to be the same number, but yes, you will physically see two variables because you're going to have one variable in one equation, one x in one equation, and then an x in the other equation. But you would never have two different numbers. If you replace that x with a number, it's always going to be the same number once you solve out and get it. Don't get too hung up on that. That was kind of just to make you think a little bit about what the concept is.
Who said 4?
A bunch of people said, actually 2 or 3 people said 4. Somebody convinced somebody else of 4. That was funny. Or maybe there was a reason behind it. I don't know. All right, so y is the total if the total is unknown. X is always going to be, so here's the next thing you can write. Try to get you some pointers. If I ask you to define x, x is never going to be a total. Never, 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 never. It's really always going to be either how many of something, or it could possibly be how much is one of them. Like, how much does one of them cost? Or how many, like we did some examples with students going on a field trip. It could have been how many students in one bus. So it's either going to be how many of them, like in this case, it's how many downloads, or they could have reversed it and told us how many downloads, and X would have been how much does a download cost for iTunes? How much does a download cost for Spotify? And in that case, we would have actually had two different values for it. Your equations were good, so I'll say yes to that. Hurry back though, because there are some other things that I'm gonna say that I want you to hear.
What?
Let's go ahead and start the equations then. So, we already said we need. I'll come back to that.
Where's the pass?
I don't know. It was in there. Did somebody go to the bathroom already in here?
No.
Son of a gun. Just go and say you're looking for our pass, and then I'll rewrite one in a minute. All right, so now we need to identify some of the numbers and how we can use them. Where does the total go, we said? Yeah, when you have y as the total. So this is again, well actually, total always goes at the end, even if you know it or not. But in this case, we don't know it, so it's going to go at the end there, and then we're going to have two equations.
Quick question.
Yes, sir.
You said y always goes at the end. Why is it in the front?
Well, if it's the unknown total. Well, I mean by itself, I should say. Because remember, we can flip the sides if we want. I could put the y on this side and then write whatever I'm about to write on the left. It's the same thing. We're just saying one side equals the other. So y is by itself. That's a better way to say it. So if the unknown, or if the total is unknown, this is your first step right here. If you're trying to figure out the total. So again, total in the race was distance. It wasn't about money. It was how far had we run. So that was the total. So we would still set it up the same way when we did that race.
Or just put the format.
What is the total made up of? It's a little bit of a stretch to see if you guys can answer this. Well, the total is an unknown, but what makes up that unknown? What's going to go on this side?
MX plus what? B.
It is mx plus b, but what are the pieces of that? You can use this equation if you or this word problem or
10.
this general word.
So what is
So what is the 10?
It's the
X.
It's the B, and then the X is like if we were
No,
doing
0.4.
if we were doing 10, then it'll be 0.5X. I mean, 0.15x plus b, which is 10.
So let's talk about how we, I want to give 10, and from this problem, I want to give 10 a word or a description that we can use for every type of word problem. It's not always going to be about money. Remember that. Money is easy to work with, but it's not always going to be about money. What is the 10 in this equation? It's the what? It is a kind of a starting fee, right? What was my 20 yards that I got when we raced? What was my 20 yards? How would you describe that? And it's got, we want to describe them all the same way. That's what I want. There's always a starting number in this type of equation.
So the starting number is always B, basically?
The starting number would be the B, because it's just a number all by itself. It doesn't matter how many songs she downloads. Doesn't matter how many songs she downloads, she's paying that $10. She can download 100 songs, she paid the $10. She can download 0 songs, she's paying the $10. Your starting number is basically, if you remember when I did the table, I put a 0 under the time column for the races. The 0 number, whatever number we write at 0 is your starting number. So if we were to do a table here, our starting numbers would be 10 and 3. So we can just start with that number. You start with your starting number. Our starting number, we said, we're what?
It's B. 10. 10 is our starting number.
10, we'll do here.
No, I
If
said
it's
it was B.
B, why are you in the front?
That's MX.
Hey, B can go anywhere. The important thing is B is all by itself. It's just a number.
Oh, so now
So
we're
what,
B can
you're
go
writing
anywhere.
it backward?
So wait, question, Mr. Gill. Oh, I got
We'll fix that later.
I got a question, Mr. Gill. What if, say, well, you
No,
can't
I
do
wrote
it.
it
You
wrong.
can't do it like
No,
this.
you're good. You don't need to change it.
I'm saying you can't do it like this. But like, say you owe somebody. Actually, you can't do it like this. Say you owe somebody. Would it be like?
Keep going. I'm answering Alondra's question.
I'm saying, say if you owe somebody, and the MX was like 0.15, right?
Right.
But then say you owe somebody, wouldn't you put -10? Because the format is
yeah,
Y.
you could absolutely have a. You're talking about for this.
Yeah, I'm saying the format is Y.
You could have
MX
negatives and
plus.
positive all throughout the. I mean, there's all kind of scenarios.
But I'm saying, if it is negative, would the 10 still go first? So it's
Could,
negative?
you could put negative 10 first. I'll show you the changing the order. Don't worry too much about that.
That was, he was answering my question. Oh, the one, the
What
Y.
you talking about?
But I'm
This?
saying,
The other service.
Remember, it's
iTunes.
multiply and iTunes.
Oh, I'm sorry. You need to write this down. Yeah, these equations are going to mean nothing to you if you don't write the last 2 sentences. So just write, for Spotify, she would pay a one-time fee of 10 and then 15 cents per download. For iTunes, she would pay 3. So yeah, I noticed that a lot of people don't have, they have the equations in their notes, but they don't have anything about the word problem to be able to try to figure out how they got the equation. So I'm going to start making sure you write down, again, we skipped the first 2 sentences. We didn't need the first 2 sentences, but we need the sentences that have the information in them. So that we can later, when we're doing a test, for example, say, okay, how did I get these equations from the word problem? And now you'll have the information in the word problem to match up with the equation.
so Mr. Gill, I'm saying, if it's a negative number, basically, what I'm trying to ask is for all this, we always put.
We'll come
plus-
back, don't worry, we'll come back to that. That's what the 2 plus 3 and 3 plus 2 was that I put up top. I know you have a question on that, so did Alondra. So I'll come back to it.
Can I use the bathroom?
Boy, I really want you to stay in here. I'm gonna leave it up to you though. I'm telling you how to get credit for partial credit or hopefully full credit for word problems. So I'll leave it up to you. You can hang in there, hang in there. I mean, nobody should be taking zeros or I mean, you should really be getting a minimum of 50% on word problems. It'd be one thing if I changed the numbers and I made you do something to the numbers that are in there, but I don't. There's all, I mean, you know there's going to be an X, you know there's going to be a Y, you pretty much know there's going to be 2 equations, you know that the 10 is going to be in there and it's going to go with a 15, you know the 3 is going to be in there and it's going to go with a 45. I mean, there's not much else you got to figure out. So we're copying the last 2 sentences just so we can match it up with the equations later. I think you got the equation right, so if you don't want to copy it, that's up to you. I'll freeze that while I check and see if somebody just joined us or if they asked a question or what just happened.
Oh, that's so much bigger. Now that I got it. That's so much. I'm just trying to find out which one.
Yeah, it's going to be really tough to do well on this quiz if you don't get pretty good points for word problem. Somebody get kicked out. I don't, in all honesty, I don't remember if you got kicked out, Devin, or if you were just now coming in, but either way. All right, so now let's go back to the equations. Oh, this. All right, so we got a starting number. That's the, she's gonna pay that no matter how many songs she downloads. Once she pays that, what's then gonna happen?
I'm gonna plus the 15.
She's gonna add more money to that, most likely, right? Odds are she's gonna download at least some songs.
15.
So we have 10. What number did we say?
How many songs you gonna download?
Well, there's your next step. We know they're gonna add some money to that. That's not the only cost she's gonna have. She's gonna add some money to that 10. And then we also said what number has to go with the 10?
15.
Yeah, if we're talking about Spotify, then the numbers for Spotify better be in the same equation, we said.
Oh, so that's where the X will go, right behind you.
So now let me ask you this question.
It's unknown.
Well, X is unknown, but we need to decide, is X going to go with the 10 or is X going to go with the 15?
I put it right there with 10, but you said that was wrong. So
technically, it's 0.15.
It'll go at 15 because I put it right there. You said that was wrong.
So here's your next thing to write down. Two things, actually. Or you can write just one of them because they're both about the same thing. X is always going to go with the number that is the number that you're adding over and over again. Like we're adding 15 cents every time we do a download.
Yeah.
So X goes with the number that you're adding over and over again. Or the other way to write it is to say this, and this is probably an easier way to remember. X will never go with the startup. Never. Because what did you tell me, Alondra, about the startup fee? What is it in the equation? What part of the MX plus B?
Oh, I know. I wasn't
It's the
even
second part, no, the first part.
But it's the B, right? We said the startup number is the B. Well, the B is not with the X, right? I mean, we just said these equations are going to follow this pattern.
It's alone, right?
So X will never go, and the startup fee is always going to be the B. So X will never go with the startup fee. Never. Never. It'll always go with the number that you're adding over and over and over and over again. So again, either way, you can write it'll never go with the starting number, or you can write it will always go with the number that you're adding over and over again. Either one of those works. So what are we going to do to the $3 with iTunes?
You're going to restart the equation.
Yeah, we're going to do the same exact thing. We're doing the same exact thing, just different numbers.
So now you're going to add.
Because we're going to add money to that.
45. Okay.
The cost over here, though, is 45 cents. And then it's going to be times the X. The
There
X
we
won't go with the starting
go.
number.
I get it now.
That's your two equations.
Now, how do we solve that now?
Well, we're not solving yet. You just always want to know the solving.
Oh, we don't solve these?
I'm going to just solve this one real fast. But first, before we get there,
I'm saying
so you guys were asking questions about, wait a minute, y equals mx plus b. B is at the end. Why are you putting the b first? I can always change the order of this later if I want. Especially if it's just addition. Because isn't 2 plus 3 the same thing as 3 plus 2?
I wasn't asking that, Mr. Gill.
Alondra.
I was asking, so look, so say you put a negative in front of that 10 right there.
I'm going to get to that one too. I think.
I'm saying.
So let's say now, so here's what Ben is asking. So again, 2 plus 3 is the same thing as 3 plus 2. So I could flip this around and make it 0.15x plus 10, and then it would be at the end. You're, I think, saying more like this.
Yeah. No. I'm saying.
Well, no, let me finish
Oh,
and tell me if this answers it. I can flip this around too, that's fine. But I need to make sure I keep the negative sign with the 3 and the positive sign with the 2.
Oh,
So
yeah.
that
Yeah.
that's fine, I can flip that too.
I kept even thinking that instead of adding, we'll subtract.
So if you're
Yeah,
saying
I'm
that
saying
this
if I
is
put
a
it-
10, I can move the 10 to the back, but I need to bring the negative sign
Yeah, I'm
with
saying,
the
will it
10.
always be a plus in the middle of those two? That's what I'm basically asking.
Right.
Again, if there is a negative sign here, the negative sign needs to stay with the 10. you could write 0.15x subtract 10 or 0.15x plus negative
Saying
10.
our format is y equals mx plus b.
There could be a negative sign. There could be subtraction.
So
An example of
Well, how would we know
subtraction.
it's
that's what I'm saying. It
I'm
won't
trying to
always-
come up with an example. We've not really done any like that. You're right, because those are a little harder to recognize. When would you subtract? What's a good word problem? Like I said, I haven't done a lot of those because they're a little trickier. So we would be taking a negative amount, starting with a negative amount. Well, I mean, technically, we could say let's say your bank account is at negative $100.
My
That
bank
would work.
account is at
That's our starting value. You have no money in your bank account to start out with.
Bankroll, no money on
So
bankroll.
you owe the bank money. Somehow you overdrew your account and you're negative.
Loan.
Well, the equation would wind up being something times x subtract a number.
Trump going.
Because technically you're still your starting number.
That's confusing me from this.
That's why I didn't bring it up, because I'm not creating it. You'll see that next
Wait,
year.
Mr. Gill.
You'll actually see it where this is negative too.
Right,
All right.
look, I'm saying between MX,
Yep.
MX, and B, will it always be a
No,
plus?
I just said.
Oh, so it could be
That's
a
what I'm just
minus.
saying. Yeah, if
But for you,
if
whenever
your bank account was negative, if you started with negative $100 when we did the other, adding money to a bank account,
Mhm.
you'd have subtract 100 at the end of that. So you could even have a negative x, like this could be negative too at the beginning of the equation. Sometimes you could have a negative, because this is just your slope, your rate of change. Sometimes you'll have a negative slope.
So it'll be negative.
Right.
It's tough.
Yeah, you could have a negative. Like, for example, if they gave you a pool, this is a very common question, you'll see this at some point. If they gave you a pool full of water, or a bathtub, or something full of water, and they say it's draining at a rate of 10 gallons per second. 10 gallons per minute. 10 gallons per minute. Well, you're starting with a bigger number, and you're subtracting out amounts over time. That's a negative rate of change. And it's also a problem where your total is not at the end. Your total is actually in the equation. That's a whole nother. Well, no, it's still your starting value though. Your starting value is the full tub, however much you start with. And then from that, you're subtracting out.
100
Your
million.
total is actually how much is left in the tub. So it still works for that. So real quick, I gotta solve this out. So if I wanna go through now and solve, and I wanna find out what's the better value, which is the whole point of this. What is the better deal? iTunes or Spotify?
Spotify. Oh no, iTunes.
Well, again,
You
these
don't
are
know
made up.
that yet.
These are made up numbers, so I don't know if these are accurate at all. So don't just assume because of what you think you know about Spotify and Apple Music.
Oh,
So-
yeah, that's wrong.
I'm gonna say
I would want to do this. I would say, well, let me put the totals and compare the total amount I pay with each service. And I want to know, when would it be the same cost? So that represents my total with each service, right? I kind of skipped the y equals y thing that we did before.
Oh.
This is my total for iTunes. That represents my total. This represents my total for Spotify. I want to know what number of downloads
Wait, Mr. Gill, time out.
would the cost
That's
be the
15, not
exact same?
45. 15.
Oh, you're right. Yeah, I just duplicated,
You
didn't
knew
I? I
that?
don't pay attention. I'll be thinking one thing in my head and write different stuff all the time. Let me just really correct that. So I want to know what number of downloads would it basically be the same with either service? It wouldn't matter. That's called a break-even point. That's a big thing in business, by the way. That's where you go from losing money to making money, is your break-even point. So if I download, and I'm just going to show you real quick how to solve it. You don't have to worry about solving it, even though Ben loves solving stuff.
Yes, sir.
So I need to subtract that. That gives me 0.30x. I still have the 3. I only have the 10 over here now. So I subtract 3, subtract 3. We'll divide now as soon as I get there.
That's what we usually do, no?
So now I divide, so I have 0.30x divided by 0.30. Then I need to divide that by 0.30. And I get X equals 23.3. Now we can't download a third of a song. So anywhere like around 23 or 24 songs. If she downloads 23, 24 songs, it doesn't matter which service she goes with. If we did the math, you'd see it would cost pretty much the same thing. They would both be, we could figure it out real quick. 23 times 0.30.
Stand up.
For real, go. Off of him.
So if she downloads 23 songs, it's about $10. Yeah, about $10 total.
What's good? What is that line over there? 3.
That means the 3 goes on forever. 0.3333333.
Oh, so.
So if she downloads like 23 or 24 songs, it's about $10 with either service. Like that can't be right.
Under that.
Can I go to the bathroom now, Mr. Gill?
Yes.
Mr. Gill, can I go after her?
Can I go after her?
Oh my.
Go ahead.
Mr. Gill, can I go after me?
Yes.
Is she? Oh,
But
she got a
that's
phone.
not right.
Phone goes in the jail.
0.15 times
Phone goes in the jail.
23 equals.
Let's get shot her for rubbish, Gill.
I know she is.
Put it in the
So it
jail.
should be like $13.50.
This
Why
guy.
did it say 25.3?
Because I wrote the wrong equation. I went with the wrong equation. Wait, what?
Under that.
So you, what's that on the
This is the number of downloads, not the money. That's the number of downloads.
Oh, it's
So
not
the
like
amount of-
25 or 20?
The amount of money is 23.
23.
That's a 3. Sorry.
23.3?
Yeah, but that
That's the number of downloads.
that's the number of downloads. The
So how she
cost
download 23 songs?
the cost would be about $13.50.
But like, how'd she?
How'd you get the call?
Just hold on. Just stop asking questions. Let me talk.
How do you?
So here's the deal. If I plug the number of downloads into this equation, that would give me how much she pays for downloads, right? Plus the 3 gives me about $13.50. I could also plug it into the other equation, and I could say, well, what if I was only paying 15 cents per download? Well, I'd say, well, 15 cents times 23 or 24 downloads, whatever you want to use, and then plus $10 would also give me about $13.50.
Okay.
So at 23 or 24 downloads, the services cost about the same.
I can't trust nobody.
So here's what I'm going to do on the quiz. I'm just telling you what I'm doing on the quiz.
I'm so off.
Well, you don't need to understand that. This is the part you need to understand.
How do you download 3.3?
Well, that's what I said. That's why I said 23 or 24.
Yeah.
You guys ask so many questions, I can never get into it.
Mind your business.
23.
Listen, right now, just listen. So, I'm going to give you a problem. And I'm going to do all of this for you. I'm going to give you the equations. I'm going to say X is the number of downloads.
No, don't do that. We need
Yes. Babe, hush.
How are you gonna get paid?
Let me talk. So I'm going to say, here are your equations. This one represents, we'll use Spotify and iTunes too. This one represents iTunes. And I'm going to say, if she downloads, and then again, in this case, it would be 23, 24, whatever number I pick, then the cost is the same with each service. Doesn't matter which one she chooses, she would pay the same. If she downloads, we'll just say 23. I'll get rid of the 0.3. It would be the same amount of money if she downloads $23. Then I'm going to say, but she doesn't download 23 songs on a regular basis. She downloads 50. She loves downloading. And then I'm going to say, what would be the better service for her to buy, and explain why.
What?
That's going to be the question. So you won't have to calculate anything. I'll do all that for you. You won't have to set up equations. All you need to be able to do is tell me which one is going to be better, but more importantly, explain why.
Spotify.
Why do you think Spotify? What was your
Because it's
explanation?
less money per download.
He started, let him finish. And then...
Less money per lot down.
So what?
What?
So
Well,
what?
the starting money is
So let me
Because
ask you
she's
this.
gonna be downloading along for
But the starter money is
More.
Because then my next question, if that's your logic, I would say, okay, well, what if I only download 10 songs? Spotify is still only less per download.
What?
How do you know that it's better then?
The starting money is $10 to start.
Because iTunes,
So what's
charges
happening?
You're saving.
They scamming.
So where am I starting with each service? So everybody try to stay tuned in. Where am I starting? What's my starting value?
$10 for Spotify, $3 for Apple.
So I'm already, if I look at my equations, I know it's been screwed up all 2 days. There. I'm already starting out paying $7 more here, right? But as I download songs, every song I download, I'm saving 30 cents up here. So eventually that $7 so this is more expensive to start out with, right? By $7. But then it gets closer and closer. It's kind of like Kentrez was catching me, or the bank account was catching up with the other bank account. As I download more and more songs, the distance between these, the cost is getting closer and closer and closer. So until I get to 23, this is the better deal. Because think about it, at 0, what's the better deal? At 0.
That's a better deal.
That's a better deal, right? Because I only pay $3. But then as I download more and more songs, the cost is getting closer and closer together until at 23 songs, it's even. Well, then it flips. After 23 songs, this is going to now be less, and this is going to be more because I'm paying that 45 cents every time.
But why would
So
you?
something along those lines, like, and you guys would have been, I think, probably fine on what you said, but I want you to understand how that matters, how that savings of 30 cents.
I'm pretty sure someone, if you buy, you're gonna listen to more than 26 songs.
Maybe, I don't know, maybe.
Who buys it and then just listens to 23 songs?
Well, I guarantee you they would buy this one, not the other one, because they'd be like, well, I might not download that many songs, so I better choose the one where I only pay $3.
Listening to the same song.
So here's the other and probably easier version for some of you. If you know how many songs she downloads on a regular basis, just figure out how much each service would cost. If I know she downloads 50 songs, just replace the X with 50 in both equations. Because this is the total amount, right? That's how much she would pay. So if I just said, well, if she downloads 50 songs, she's going to pay, and then times 50, and then down here, I'll do it in green again. Down here, she would pay this much. And then do the math and see which one comes out to be a better deal. So that's a second way to do it, is just to literally calculate the total cost out and figure out which one is the better total cost. So you can show me either way. You can explain it in words, or you can go ahead and you can just do the math and say, well, this one would be a better deal because it just costs less.
Wait, we just went over this, so we don't have to.
Well, I just went over a whole second way to do it, which you probably missed because you were conversing.
Ready?
Get out your sheet with the elimination, solving by elimination.
I ain't got that. Can I get that?
Is that the
No,
packet that we
you
had
can't
in
get
last
it.
class?
Yep. I do not have any to give you more of them. I will put it up on the screen. You can copy down all the problems as we do them, but if you aren't here, I have some for people that are not here.
Look, look, look.
I'm going to check and see if you are not here or not, but
You don't gotta know.
Don't say that to me. I'm gonna get you a new pen.
let's see who is truly not here.
Yeah, I'm poor. I can't afford a pen.
All right, Alondra, you were not here.
You just said my name.
That don't mean I'm talking.
Braylon, you were here.
This is athletic class.
Last class.
That mean I'm talking to you.
Yeah.
Well, that's not my fault, bud.
Say the move.
What?
You're not married.
Bro, I'm gonna call her.
You don't know her
The
number.
only one I didn't have papers for were
She said that's not
sixth period, and I had somebody make copies of sixth period. Some people left it in here. You might have been one of those, but you don't. There was no name on it, so I don't know who it was.
Yeah. You know
So you can copy them down when I put them up.
Son, what?
Again, you guys have got to take care of the stuff when I hand it out. So
They
I'm
copied those up real.
not going to continually make more and more copies for people that forget stuff. So
Mr. Gill, I got a piss off you. Mr. Gill, stay.
one more.
Bro, what? No, bro.
All right,
Yeah, bro,
so
sit
I'm
up
gonna
here,
go
you
over
sit back
one
up,
we
listen.
already did real quick, and then you're gonna do 1 through 4. I think you already started 1 through 4, but
No,
to give you time to do more.
One. That's it. All we did was one.
Well, that's 1 through 4. You started
We
one.
ain't have enough time.
All right, so here's your review. A problem like this. Here's the exact process you're gonna do in every single one of these problems. This one's already set up really easy, but they're gonna get harder as we go over today and tomorrow, or next time. The first thing you look for is, do either of the variables have like the same number in front of them? Do either of the variables have the same number in front of them?
No.
Well, we're gonna say yes for now. I'm gonna tell you something else. Technically, it's 3 and -3, but we're just talking about just the number part right now. Yes, y has the same number, the number 3. The next thing we want to look at is, do they have opposite signs? Because that's what we want. We want the same number, but opposite signs. Well, yeah, that's positive and that's negative. That's our goal with every equation that we try to solve out by this system of elimination thing, or this process of elimination. We want the same number, but opposite signs, which we already have here. So we can just go ahead and solve this one. We do this by adding straight down, because we said we can add whatever we want to one side of an equation as long as we do it on both sides. Well, technically, this value right here is 10. We don't know exactly what x and y are yet, but we know everything in there should be 10, because it tells us that right here. It says that equals 10, so this needs to be 10. So I'm adding 10 to 14, but I'm actually adding 10 on this side also. It's just in a different format. Like it's like adding a dime on one side and 2 nickels on the other side. Still 10, but it's a dime and then 2 nickels.
Don't say that. Don't say that.
You might already have this in your notebooks. If not, you better make sure you write it down. This cancels out.
0.
That is our whole goal, is to get one of the variables to go away.
Please don't.
So please write this down right now when I say it. If anybody says this, again, I may need to carry my ruler around.
Hold on.
This does not mean x equals 0. It means in this second equation, we don't have any x's. There are no x's in that equation.
Okay.
Does not mean x equals 0, though. It is 0 times x. Because that would mean this x equals 3 then, if we were following that logic. And this would mean x equals -3. Well, x can't be all 3 of those things. So 0x does not mean x equals 0. So now our next step, now we can solve for y, because we really don't have any x's in the equation anymore. They're gone. They canceled out, which is what we wanted to happen. This way, Ben, like, I don't know who distracts who, but
What?
like, you guys can't afford to do poorly on this next quiz, and right now I'm not going to feel bad about you guys.
What I did?
It's just non-stop, like
That was
the conversation.
doing it for the day.
Well, that's not what it looked like. It looked like a bunch of conversation. You staring, laughing at him chatting to himself, or whoever he's talking to. I don't know. But you seem to be enjoying it. So, y is 8.
That's funny.
Deja woke up there.
For real. I got my son up here.
Put that up on the board, please, or in your backpack.
Got my son up here doing his
You
work.
break that thing.
That's crazy.
I just did the first step for you. I completely solved it out. You already had this from the other day. You should, unless you weren't here. Here's the part where people are not getting it. A lot of people are getting this first part. They add it, they get the y. You are not done. We don't know what x is. X is not 0. I just said that. You need to go back to one of the original equations, and you need to say, well, wait a minute. I now know that y is 8. Y is no longer a variable. It's not an unknown. It's 8. Y equals 8. So I don't need to have y in these other equations. So I could get rid of it. You don't need to do it in both of them. You could if you wanted to. But I need to replace y. I'm doing a different color. So 3x is still in the original equation because we don't know x yet, so I can't change x. Y, however, is not. We know what y is. If I know what y is, I'd rather put the number there. So I'm going to put the number there. Now we only have one variable in the equation. We can solve for x now. X was not 0. We haven't done anything to solve for x. So I would say 3x plus 16 equals 10. Subtract 16, subtract 16. This is just a two-step equation, so I'm going to go pretty fast. So we get x is negative 2. So that's the next step you have to do. You've got to go back and solve for the other variable. Now here's the next thing that's been confusing. They start out by canceling the x over and over again. If you'll notice, I canceled the x. It's not always the x that cancels out. If I would have had an equation that was like this, so if I would have had x plus 2y equals 7, 3x subtract 2y equals 10, that will do 11. If I add these straight down, I get 4x plus 0 is 18. The y's canceled out here, so I have 4x in this equation. So I would solve for x first. So here we solve for y because the x's are the ones that went away. Here we would solve for x first because the y's were the ones that canceled out. So don't think it's always going to be the x values that cancel out. And then I think problem number 3, it's not the x's, it's the y values that will cancel.
Could you come check and see mine, right?
Yeah, so you guys do 1 through 4 right now. You're not going to finish them, but I'm going to do the next part of the lesson in 10 minutes, 9 minutes.
Could you come check mine real quick?
And the next part's harder, so this is going to be the easy stuff on the quiz when it comes to this part of the quiz.
I just got lost completely when you did all that.
Well, we did it the other day too, so.
Alright, go this one.
Yeah,
No,
she
mine, you don't
knows.
like. Go check that one. Yes.
Good, so 0, that is 10, that is negative 10, so you get negative. No, you gotta divide. You gotta divide out by that number. You got 10y equals negative 10, right?
Already put it right there, negative 10.
Yeah, but y is not negative 10.
You should know you said 1 before.
10 times y is negative 10. Y is not 10.
Can I get erased because I messed up?
Do you see what I'm saying?
Yeah.
This is 10 times y.
So we're
10
dividing by
times
10.
y, there you go, yes, exactly, good.
It'll be a negative 100.
Oh, you wanted to capital this earlier.
Want to be like a negative 100?
What?
Like a,
10 divided by 10, or negative 10 divided by 10?
it'll be like negative, I don't know, something, 0, something, right?
You said 0 on one of the quizzes before. No. What's 1 divided by 1?
0.
What's, no!
I thought you told me that. A thing divided by itself is 0.
No.
No.
Division means you're splitting stuff up into groups. If I say 6 divided by 2, that means I'm taking the 6 and splitting it up into groups of 2. So I would have 3 groups of 2. 6 divided by 2 is 3.
So one group,
So
one
I'm
is
taking
one.
one group of 1. So how many groups do I have?
1.
That's 1.
So it'll be just
Anything
10.
divided by itself is 1. Now if you have a negative in there, you have to take that into account, obviously, but.
I don't,
Yeah, a million divided by a million is 1.
but I do it for each.
You want to write it on there? Shot that
I did, but I don't know.
Shot that bag.
Wait, is somebody out in the back?
Ella,
Who?
No,
Somebody go. She does see.
shot that bag.
If we have time. Should, hopefully.
I got stuff.
Shot that bag.
Yeah, so now you need to take that bill and solve for X. That way.
That's the part that I got lost in.
Everything in green. Well, that's because in my problem, that's what y was equal to, was 8. So that's where that makes
Okay,
sense.
so we.
You would use whatever you came up with and replace the variable with whatever you came up with, which I think was negative 1.
Okay, I get you.
Why?
So yeah, divide by what you just said earlier.
9. 1.
Yeah,
9 divided by 9 is 1.
I know, exactly. So you're on probation.
9 divided by 9 is
Yeah, because that's not the first time that's happened with you.
Wait, a number divided
Well,
by itself
I don't care.
Don't get disrespectful.
So, I mean, she's being disrespectful to you guys. You guys are the one that are sitting in here forever
I'm not
waiting.
being disrespectful.
Don't be disrespectful. Yeah.
Okay, maybe not disrespectful, but you're certainly not being considerate. And I got people in here about to go to the bathroom in their pants.
Number
Don't be
divided by the
disconsiderate.
same-
Let him go out.
A number divided by the same number is
Yeah, don't be
1,
rude.
right?
Yes, thank you. Go ahead, you almost said 0.
You can get it wrong now.
All right, so 1 through 4, go, go, go. Because I'm about to start the next part, which is the harder part.
Finished.
Get at least one of them done, so I can check it. This is not going to be due today, but it'll be due soon, once we finish going over all the different types.
Is this the worksheet that we did last time?
We started it.
Negative.
Yeah. Oh, you can get a calculator if you want. There's this thing full of
How do you know?
calculators.
What if you said it was wrong?
Game, range it, you can it. I like NBA. Oh, it's a fresh one. Okay.
Can we work with?
Yeah, we should.
Not on this part, because I'm about to stop in 5 minutes. The next part, yes. Absolutely.
So what you gonna do?
Because then you're just going to work until the end of, although you two can't work together.
Okay, never mind.
You two just wind up arguing.
Oh, what?
No, it's not. Yes, it is. No, it's not. Yes, it is.
Sure, but listen anyway. Hey, you stuck.
Who did I just take? Oh, Michael.
I'm serious.
So -1.
Can I see so I can open it first before you bring that mess up?
8, that's 28. Alright. Now that you worked on this with your tutor,
Push it.
so keep, how much of it have you gone through with her? 'Cause she might even be ahead of us. We haven't even gotten to doing these types yet, which it looks like you've done.
Mr. Gill.
Yeah.
She ran
To be honest, I'm touching you. You're from me like that before. Yeah.
The guy got a
This is a
question.
different, this is a different type. 5 through 8 is different than 1 through 4.
I got a question.
You got about 3 minutes before I do the next piece, so please try to do
Stop talking to him,
it.
stop talking to him, stop talking to him. Period.
1 through 4 right now.
Wonderson, what up, boy?
I mean, I'd rather you do the lines accurately.
What up,
Then if you want to cross out, but just make sure you keep them
Wonderson, what up,
in a
boy?
straight line when you're doing
I
that.
can go like that, right?
Question mark, like, why did your parents name you Wonders?
Or is
That's not 6. That's 10. It's
Yeah,
positive, positive.
She doing that ass. I'm asking a question. She right.
And for this one, you like.
Did you copy down what I just did up there? Yes.
No.
Use this example. It's just-
Yeah.
it's really just like-
Wait.
Really? Come on,
These
I'm
are
ready.
three scale solves. So all you do is add straight down. No.
Yes, you do. Stop listening to that.
Yeah, but this is negative right here.
I know.
Wonderson, don't help her. She's trying to tell you what to do. Don't help her, Wonderson.
So with pins in your add, which one's higher?
So I'm trying your
Put it in the
pocket.
calculator.
He came back.
Alright, hurry, hurry, hurry.
So tell you, your dad climb up. Alright, yeah.
When you guys use these calculators,
Respect your pops.
people are still putting in. Gentlemen, please, knock it off. When you're putting numbers into these calculators, if you need to put in a negative number,
Wait, never mind.
you need to put the number in first, then hit the positive and negative button. I hope you heard me. I'm not explaining anything.
So the first one, this is the
Man, I'm talking to you.
Negative
Yeah,
1
really?
is the first. Yeah, because it should have been a negative.
Producer.
And then you need to put that in and solve for F.
She was not talking to you. I'm just saying she was talking to you.
That's a
Fuck,
negative.
no, That's all you say.
That's we're actually a part of the class. You guys did a class.
Don't start with me, what?
I'm listening.
Okay.
Well, again, that would go away. No, you would never do that.
Yeah, buddy,
That
buddy.
just means there are no x's in the equation. Then you would go solve for the y. If you have a 0x or 0y, that means there's nothing in there. Not really. And then use that, then use
Son,
that.
what did you do? What did you work? What?
Plug that into either equation and solve for
Yeah,
x.
work out.
Calling me.
Oh my son.
What I did in the
Talking to
game.
your pops like that, what? I beat you like a slave, what? Talking to me like that. Son.
So look,
Tell you,
Because you woke up,
No,
your
for
head,
why?
your eyes.
I ain't lying, son. Do that work, bro.
That's what
My son.
Oh, so now you are sleeping.
My son. Do that work.
When did you get high?
Oh, you divide. I think you said 20.
Because they don't give a shit.
This is 20 plus.
What are they gonna do?
So if you do 20 plus negative 30, then you did everything right. That'll give you the answer for why.
This is getting high.
Not now.
Go ahead.
So you're gonna keep one high.
That looks good there.
Well, last weekend.
Yeah, that looks good there too.
You're smoking that.
This is like the plug-in.
Yeah, perfect.
Okay.
And you can pick either equation. Now, if you do it for both, you're gonna get the same answer. So like if you chose one equation and the other equation, you still better get the same value.
How do you do that?
That's actually a good way if you're working in a team to check it. You take one equation and then do the other equation.
Hey, Tom,
Because if you both get the same answer, you know you're right.
stop talking to him, please.
Yes, correct. If there's just a variable, absolutely. All right, I gotta go ahead and do the next step, which is, again, oh, this gets a little harder. I mean, yeah, it could be a lot harder for some people, I don't know. We'll see how you do. So everybody stop working, stop on 1 through 4. You gotta see this next piece, because this is a lot harder than what you're doing right now. Well, I mean, again, it depends on the person. It seems to have been very difficult based on what I've seen in other classes. So what did we say we want to look for first when we're solving these systems of equations out, like by elimination? What do we look for first? What was our first step?
You look for to cancel out the x's.
Well, first we look for a variable that has the same number right in front of it, the same coefficient number.
X.
So in this case, we have a 2 and a 2, or a 1, right? So that doesn't work. But for the x, we do kind of have the same number.
1 and a 1.
Actually, we have exactly the same number. What did I do on my pen? We'll just go to red. So here, we do have the same number. So our first step is find a variable that has the same number if there is one. Now, here's the problem with these next 4. When you do 5 through 8. Shh, you don't need to be turning around talking to them.
I'm telling you, my master. Ma'am.
So, we don't have two numbers that have opposite signs. They're the same number. Like we have a 1 and a 1, which is the first thing we check. But we don't have opposite signs. So if we just added this straight down right now, I'd get 2x plus 3y equals 17. That does me no good. I cannot cancel out if they don't have opposite sides, and I can't solve if I still have two variables in the equation.
Question.
Impossible to solve. Nope, no questions. Let me go through.
Uh,
You guys asked before I'm even done doing anything. So here's what we have to do. We have to get one of these numbers to have the opposite sign of the other one. It doesn't matter which one we choose. You can choose whichever one you want. And again, this is where I lose people, right here.
Oh.
If I have the same number, I need to get this to be, or this, I can choose either one. I'm going to choose the bottom. I am going to basically multiply both sides of the equation by -1.
Okay, to
And
cancel
we
out.
said, well, it doesn't cancel out. We said I can do whatever I want to an equation as long as I do it on both sides. So when I multiply by -1, what it basically does is it says, okay, well, what is 1 times -1? I'm always
1 times -1 is -3. I meant, wait.
What?
That's 1 times -1. So again, we actually have a 1 in front of that y too. I have to multiply that times -1 also,
Wait, why'd you put
which again is -1.
Why'd you put -1x?
Because I just literally said
Hell,
6
listen.
times what I was going to do.
No, listen, I'm talking again.
And then
What?
I need to make that -7 because -1, so I got to do it to the other side also. -1 times +7 is -7. So now, if you'll notice, so this equation is gone. I changed that equation. I took so I'm answering your question now, and so don't anybody ask it again.
Don't tell them no more. Don't listen. Don't tell them no more. Don't worry about it. You gonna
I'll
listen.
wait till I'll eventually answer when I don't hear anybody talk, which may take a while.
So that should be quiet.
All right, so here's the answer. I changed this second equation. Again, I can do anything I want to an equation as long as I do it on both sides. So what I did is I said, well, I need to get this was a positive 1x. I need that to be a negative because I need them to cancel out. So I just said, well, I'm going to multiply every term by negative 1. So positive 1x times negative 1 is negative 1x. Positive y times negative 1 is negative 1y. Positive 7 times negative 1 is negative 7. Here's the shortcut version. So I would write this down in your notes. If you get to the point where you have the same number in front of the variable, but they also have the same sign, meaning they're not going to cancel out. So I'm going to rewrite the equation over here so that it's, so I have, what was it, x plus y, I'm sorry, x plus y. So this was my equation, the second equation that's underneath the red. That was the equation. I don't want this to be positive because if I add, and there's a 1 there technically, if I add this and that, it gives me 2x. I don't want that. I want them to cancel out. Or I might want the y's to cancel out, but the problem is there's a 1 here and a 2 there, so even if they're not going to cancel out no matter what I do yet. We'll get to those later. I can do whatever I want to this equation as long as I do it to both sides. So all you do is you just change every single thing to the opposite sign. Doesn't mean they're always all negative. It means you have to flip the sign.
Because the root cancel out, you
So
gotta
if
make
it
more
was a
negative.
negative, you would change to a positive.
I was just going to go, so now look at number, I think 6.
Five.
Well, 5, they're all negative. I don't like that. Look at number, actually, no, look at number 7. You see how number 7 has negative 6 plus 6y equals 6.
So there's a negative cancel.
So if I flip the sign of that top negative 6, because I wanted to cancel out with the negative 6 right below for the x's.
You gotta flip them.
Here, actually, I have this up here. Hold on.
You gotta
They
flip,
make all of them positive.
you gotta flip the.
Well, no, you
negative.
don't. That's what I'm getting
That
to.
negative 6, you make a negative.
Be negative 3.
Hold on. Let me. It's okay. So everybody, look at number 7. So here's number 7. So if I were going to do, and right now, if I add these together, I get negative 12x plus 9y equals negative 6. That does me no good. They didn't cancel out. That does me no good. I still have 2 variables in the equation. So I can't do that yet. I can't add vertically yet. I'm not ready. Now I do have the same number part, like it's a 6 and a 6. I want the signs to be opposite. So to get the signs opposite, I just flip the sign of every single thing that's in that equation. Because that's what happens when you multiply by negative 1. So this becomes, now again, I have to flip everything. So plus 6x. Now I flip the positive 6y that is next to negative 6y. And then on the other side, I flip the positive 6 to negative 6. So you don't just make them all negative or make them all positive.
That's why I say you flip the
You
sign.
flip the sign of everything. Don't forget to flip any
So
of it.
every number you gotta flip.
Yes.
Okay. then.
Yes. Well,
Like
once
you
you
say,
get
you're
to
gonna flip
this
everything.
stage. Well, that's what's it.
He don't listen to
You-
me.
no,
Don't go over no woman's again. Go ahead. He don't
I
listen.
know what you're saying, but never mind.
I thought I did say that. So if I
You said
didn't,
you
that's-
can't. You
I
said
want that
in this
up.
situation you don't flip everything.
No, I said you don't just make them all negative. I said you flip them. You don't just make everything
Yeah.
negative or everything
Never
positive.
mind.
You have to flip every individual sign.
I was wrong. I heard you wrong. I know what I'm.
I think, I mean, if I didn't say that, that's what I meant to say.
I want that
You've already done some of these, so.
sign.
So now, if you'll notice, now these will cancel out. So I kind of already set 7 up for you, so that might be a good one to start with. But you need to practice doing one of those on your own so you know how to do that first step of picking them. You only do that for one equation, by the way. Don't do it for both equations. Because if you do it for both equations, then they're still not going to cancel out because you flip both signs. So instead of it being negative 6x and negative 6x, you just made it positive 6x and positive 6x. That still won't cancel out. So only do it for one equation. All right, so you guys go ahead.
What about setting up?
Can you take your hoodie off for me, please? Hoodie off? Yeah, earbuds out. Come on. So hoodie's always off for you then, because you just, well, the trust factor is gone. No, bud. Sir, I know you can hear me. You guys get to work.